Alright, hey everybody, I hope you all had a great weekend. Mine has been really good, and today is just, well, the weather is just finally a cool day in Houston, so I'm super excited about that. But yeah, it's been a pretty good weekend as well. Starting to feel like fall finally. But let's get right into it. So today we're going to work more on the 2D lights project, and unfortunately playing around with a stencil buffer, which we had started on last week. I read up on it more some this weekend, and I actually am pretty sure it's just not gonna work for our project because the stencil buffer, I think, is reset every time you render. Well, that's one problem, and also we're trying to set the stencil buffer in the context of the cutout camera, which is, I can't really see it because it's off, but this little square. And obviously it doesn't go to the entire screen space, so I don't really know what I was trying to do. I guess it was late, and it seemed like a cool idea. So the stencil buffer definitely works for certain kind of masks, but unfortunately not our project. So, excuse me, every time I stream my voice seems to go out, but I'm going to try and, just a second. Alright, so what I'm going to do is just kind of revert some of that work that I did yesterday. Luckily not too much having to do with the stencil buffer, and we're going to go back to using the texture method, which seemed pretty good, except the problem had to do with sorry, I'm trying to write and talk at the same time. The problem had to do with the each having to render the mask for each light was starting to get really slow, and I think I might have figured out a way to fix that problem. So basically right now the camera only renders one light at a time, but what if we just put up a bunch of lights and the camera rendered the whole thing, like mini lights at the same time, basically all the red lights, for example. That way we wouldn't have to we wouldn't have to have as many render textures and as many draw calls, and also our shader to combine all the textures together, this combined 16, would be a lot simpler, and we could just go back to our 4 textures to 1, where it just reads textures and inserts the red value into each channel. So yeah, that's nice. Although this shader still seemed to be really fast even with the if statement, because when we were looking at the performance the other day, the blit operation, which what runs this shader, was only like 0.02% of a frame. That's nice. Alright, so what else do I need to do here to update? I guess we gotta get all this back and get rid of the stencil. And then we create all this again. Okay, so we'll get the visualizer back. No more stencil material, and then we have to set the texture again, and then blit at the end. Okay, so, oh yeah, we do want to do this, don't we? Okay, so now I think everything should be back to how it was before. I might need to fill in some values here. That's created, I think. Okay, yeah, we need to change this. The shadow cutout just needs to be a white texture again. which I think was, we had to do unlit texture because for some reason it didn't work with just the unlit color. We could probably make it either even simpler texture here if we wanted, or a shader. I'm not really sure if it matters. Okay, so let's, I'm just gonna play and see what happens. Okay, so it seems like things are still being written to the buffer, but the lights still haven't, they're not working. So I gotta figure out what code I messed up, or not messed up, but modified the other day. Okay, so we set this. Maybe right here. Oh, I bet the texture is different. Yeah, mask from stencil, I need to change it to select quadrant. I think that's all I have to do. Yeah, there we go. So everything's back to how it was before, and it works pretty well. Let's close a lot of this so we can actually see what's going on. The only problem, of course, is that we have so many draw calls, which we can see here, batches, and that's just because for each light, the game has to render one texture to get its mask. So ideally, by rendering many light masks at once, we can at least reduce these batches to, I guess it would be 1 for each color. So 4. And then there'll be one more batch when we call graphics blit to combine them into this texture. But it'll still be much simpler. And then if we look at our, let's see, profiler, yeah, see the green part is rendering, and so obviously that's where we need to try and take things down. The yellow part is still idling, and then the blue is our script code, which I'm guessing most of this blue, it's actually just the camera render and the blit still. So our code that figures out the shadow meshes is actually barely, doesn't even register here. Yeah, the blit is 0.3%. compared to each, well, the camera render is 43%, and it's called 16 times, so we can cut this down to 4, which should help a whole lot. Okay, so that's what we're going to do today, is just kind of clean up some things as we go. So we might as well just make our own very simple text, our shader here that just returns white. Actually, I think I might clear out some of these shaders. We don't need like these stencil ones. I already have a white shader actually. Yeah, because they're not, we won't need them in this. And this is really old, but I'll keep it just in case. Okay, so yeah, all this does is just return white. So that can be the shadow cutout. And it still works fine. So right now you can see here these white rectangles as a shadow mesh for the very last light, which is alpha 3, and it's fine, but it goes way outside the bounds of the light, which is actually just this really small area, You actually can't see it because of that. Well, the camera's actually off. But yeah, this little square is the only part that the camera actually renders. So we could speed things up. We could maybe even skip a light if everything is out of bounds and not even call render. I wonder. Well, I guess that won't matter in our new system. But another thing we need to do is if we want to have multiple lights rendered at once, then these meshes will need to be clipped to not go outside the bounding box. So before we update the system to draw more than one light in one draw call, I figured that we better fix up the mesh creating code, because right now it's super lazy. We can do that here. A lot of the supporting code works fine. What we really need to do is two things. Before we used to raycast, we don't want to do that anymore, so we'll need to go back through and do a more mathematical approach. Basically, we'll just solve for the x and y intercepts for the line when it reaches the sides of the box. Yeah, and then we'll need to, we might not use exactly this equation, but, or this function, because another thing we'll need to do is figure out, yeah, the hit normal, so that we can tell if we hit the top, bottom, left, right, or whatever, and that will change the shape of this mesh that we'll create. So let's see. Let's make any numeration just for the side that will hit. I guess we can just call it side. So top, right. That's not how you spell bottom. So I guess what we want to do is we'll want to have a point, and then a direction, and then we'll return this hit point and then this side. So let's make it not even care about the index. To direction and point, and so we won't do the normal. I guess we'll just do hit side. Okay, so let's see. If we have the point and direction, we can get, well, actually we can just take this as a unit vector. Yeah, I'm trying to figure out the best way that I want to do this. Actually, we know the direction is just, yeah, I forgot, because since the light is always at 0, 0, then we don't even need this direction, because we can just call point normalize and that will give us our direction. So that makes it easy, because then basically, unless the point is at 0, 0, then we can find the we can create a line using this point and vector 0, 0, because every line will go through the origin. Yeah, so let's just not worry about edge cases now, but I'll put a note here. What if point equals vector 2, 0? So now we can see we can find the slope of the line and just do some basic algebra to find when it collides with the bounds of the box. Okay, and then we can see like what direction it would be by just, since the point is at 0, 0, we easily just tell like it would hit the right side if the x is positive, for example. So that does simplify that a little bit. But anyway, let's see. So we'll have the vector 2. Well, I don't need difference because that's just negative point. So the float slope is point y divided by point x, except inverted. Oh yeah, and if x is 0, then obviously that's a problem. But yeah, I'll come back to that later. Okay, so yeah, it would be slope, yeah, because it's basically vector 2, 0 minus point. I think that's right. Well, no, yeah, it's not negative, okay. It is, I'm trying to visualize it in my head. If we have a point 1, 1, which is out here, then the slope would be positive, so yeah. Okay, so now we of course need to find the b so that we can just solve slope times x plus b. So that means, let me just do a little algebra. So y minus slope times x equals b. So again, we can either use 0, 0. That's probably not the best choice. Yes, we can just use the point. So point dot y. Oh wait. Intercept. Oops, can't spell that right. Y. And I do apologize if any of this ends up being wrong. I've been programming all day, so by this point of the night, sometimes my brain is not in math mode. But it's looking fine for now. Okay, so now that we have the slope and the y-intercept, we can just find the x and y values for anything we want. Okay, so I guess we want to, if point x is greater than 0, then we know it'll collide with the right side. But we probably should do it something like this. Horizontal side. And then, so what we do here to find the horizontal side is we need to solve for, we need to solve for y for the right bound. So how do I, well, this would need to be provided, I guess, with the bounds. So vector 2 bound radius, and since it's centered on 0, 0 again, we might as well just use the radius. That'll be the easiest way. Maybe this could be in the data instead of having to pass it separately. I don't really know. Don't think it makes a huge difference. So now, okay, I guess we'll do it this way. Vector 2, horizontal hit. So obviously it's bound, the x is just the bounds because that's what we're checking, and then the y value would be we just gotta solve for this equation right here. So slope times bounds radius x plus the y-intercept. Oops. Okay, and then if point is less than 0, well, for right now we'll just pretend that these points are never at 0, 0. Then it's just negative and negative. Okay, so if the y value here is outside of the y bound radius, then that means that we need to, that's obviously going to collide with either the top or the bottom of the box. So I don't know. Yeah, we might be able to just stop it here. So let's see. If horizontal hit dot y, I guess we can do absolute value is greater than the bounds radius. Oops. Okay, so if this is true, then the hit side is... Oops. Oh no, yeah, I did this backwards. If it's less than or equal to bounds radius, then I guess we'll just default to it being the horizontal side will take precedent over the vertical, and then hit point equals horizontal point. We probably don't need these variables actually now that I think about it, because yeah, we only have to calculate the vertical collision if this is greater. So yeah, I'll do it like that. So this means basically the hit point again is outside the bounds, so that means it's going to that it actually collided with the top or bottom bounds before the horizontal bounds. So we basically just need to do the same thing again except for the y. So again, if the point is greater than 0, then that means slope is positive. I guess we could have also done this if slope is positive or negative, but so we'll rearrange this equation because we want to solve for x. So let's see, it'd be, I think it's y minus b divided by slope equals x. I guess I should do it like that because that's more programming syntax. So I did that right, correct? I didn't show my work, but I think that's okay. Okay, so here the hit side is the top, and the x is where we're trying to see where it collides again, so it's bounds radius y minus y-intercept divided by slope, and then the bounds radius dot y. Same thing here, except we're hitting the bottom, so we've got to use negative values. I could flip that around, but I'll just leave it. Alright, and then none of this. Yeah, I guess we'd have to return 0 if the point is... Another problem is, yeah, if the point is outside... Okay, well we just won't... Actually, yeah, if the point is outside the bounds, then... Actually, what would happen here? I think these would just be like invalid points. Yeah, it's not like we get an error, but the points would just not make any sense, I think, is how it would work. Yeah, so if we get down here, will we turn true? But let's see, if point dot x I guess I can do it this way. I'm not sure if this is faster than testing each by itself, but also what happens if it's exactly on the bound radius. So we'll just kind of test for everything we don't want to deal with right now. So yeah, if the point is 0, or approximately point y is 0, if either of those are true, then we just are not going to deal with it right now. Complain to us because we have to set these out variables. Actually, is this going to be... Because yeah, if this isn't gonna work, because actually what we should do is if it's outside the radius, we should clip it into the radius. Because yeah, if one point in the segment is inside the bounds, then we need to still create a shadow, but we would just clip the outside bound point to the bounds, which is not super hard to do, but this, yeah, so this function wouldn't take care of that, I guess. I guess we don't need to send the light. Okay, so obviously there's still a lot we need to do. We need to take care of things that are outside of bounds, and then we still don't deal with these normals, which lets us know if we need to create extra points. I think we're at a good part to start. Oh yeah, I need to pass the bounds. Which, how big is the camera? Okay, so it's 2 by 2. Okay, so yeah, things are looking pretty weird. And again, I think it's just because the code is just not going to deal with things very well right now. Yeah, you can kind of see. It's just when things are out of, you can kind of see like a little mask triangle in the bottom left quadrant. The blue triangle sort of works right, but it's just really hard to tell because if anything is out of bounds of the light, it just messes it up. Also, the points seem to always go to 0, 0. Yeah, so I think in order to really test, we might just need to kind of start from scratch here. And we should probably test all these things before we actually start yeah, before we call this function, because that would change the topology of the, or how the mesh looks. Alright, so let's see. So there's a couple things that could happen. Either both segments could be in the camera's range, which is what we handle right now, or one point or the other point could be in the bounds but not the other, and then both are outside bounds. So if both are outside bounds, that's the easy one. We just don't even have to deal with it. And if only one point is inside bounds, we need to interpolate the second point to get it onto the bounds. So maybe, well, each segment, I was gonna say maybe this segment should have like another, like, I don't know, tangent vector that we could pre-calculate, but every segment is only read from once, so it doesn't really make a huge deal. Although actually, now I think about it, we should create all the segments at one time, and then, because we'll have to loop through each time for each light. And then we'll just apply the light offset when we actually calculate them for that light. Okay, so yeah, maybe we will go ahead and have tangent. Which will be, well, I'll have it point towards A. So that way we'll just have that already and we won't have to calculate it every time. Okay, so basically we'll need another function to find segments. Yeah, we won't do the light offset now. Yeah, because this is all independent of lights, so yeah, we only need to do this once, and then we can call create lights a bunch of times. Alright. Okay, so let's figure out again if a point is in or out of the bounds. We don't need that. Private bool is in bounds. And that's just this code right here. Okay, well, let's just not use abs because I'm pretty sure it will be faster if I don't. So if point x, I think it'll be easier actually if we do, well, it doesn't matter. So if it's less than or equal to bounds radius x, and point x is greater than or equal to negative bounds radius x, and point y is less than or equal to y, and point y is greater than or equal bounds radius y. Oh, this should be negative, obviously. Okay, so that's pretty simple. We'll actually probably take out this part, but for now I'll just leave it in. So we'll have vector 2a equals segment a plus light offset. Actually, it should be minus. 2b equals segment b minus light offset okay, so I'm trying to figure out. Okay, let's separate this into a different function because it's going to get pretty big. And really, we don't really need to know which one of these is in or out, or the rest of the code doesn't. We just want to get 2 valid points. And then I guess if neither are inside, then we just skip everything else. So let's see. Private bool is segment in bounds. I guess we can just pass the line segment. Yeah, because we will need the tangent. And we'll want out vector 2a, or let's just call it point A. And this will return false if the segment is just completely out of bounds. So bool A in bounds and B in bounds. Oh, actually, if both segments are out of bounds, they still could cast a shadow if the line intersects with the wall, with the bounding box. So maybe, how do I do this? I guess we basically need to do the wall collision, but we have to do it. Yeah, if they're out of bounds, we basically need to go the opposite way, the opposite direction towards the bounding box. We have to run the same code. And then figure out if it hits, if the line hits the bounds at any time. Okay. But I guess we still do need to know this. So let's just do it one what's the word? One possibility at a time. So if they're both in bounds, it's really easy. Point A equals segment A. Point B equals segment B, and then we just return true. Because if both are in bounds, then obviously it's going to cast a shadow. And then so with this code, yeah, it'd be different if A is in but B is not. So yeah, we should have to if point A in bounds. So B is out of bounds. Find the collision with the bounds along tangent. Okay, so unfortunately, a lot of this code assumes that all the lines go through the origin because they do for the shadow mesh. And I'm trying to decide if I want to make a general line casting function that would maybe be slightly less optimized, so I can use it for this code as well. Probably a good idea. And then if for some reason we find out that it's really slow, then I can separate the functions out later and have this more optimized version. Okay, so I'll leave this here for now. I guess I'll just leave it forever as a comment, so that way I can use it as a starting point if I do need to go back. Okay, so find collision with bounds. So we'll have the vector 2. Okay, I guess I could do point and direction. And we won't really care if the direction is a unit vector, so that's fine. And then we'll still want out to hit point and out side, because we'll still need to know the side that we hit. Maybe I should just make another variable that's like, I don't know, point that has the position and then the side that it's attached to, because I think that we are going to be passing that information together a whole lot. So let's see, what do I want to call this? I guess point. And so we'll have position and side. And so if we're going to do that, we need to have another value here for none. And I'll go ahead and make a nice constructor here, why not? Okay, so yeah, now we'll still need to have out, but we could just say out point. Oh well, this would actually, yeah, we still need 2 here for point A and point B. And so this, so isn't bounds. That's a bit of a shame. The problem now is that this isn't bounds. If it's right on the bounds, then we'd want to know. Alright, so how do I want to do this? I guess we could just do approximately a bunch of times. Okay, so let's actually take a point. We'll do it like this. And there's also the possibility of a point being in the corner. How do I want to do that? If a point is in the corner, that would be a different edge case we would need to think about. And I mean, it's unlikely to happen, but over time it could. Let's see, I think I think how the game would probably handle it is it would just create an extra vertex right on top. Could that cause problems? I think if you do have vertices that are on top of each other within the same triangle in a mesh, that can cause errors. So yeah, we might need to take that into consideration. Although, let's see, when could that ever happen? So basically, if one of these, let's see, well, I mean, there's two ways. Either a segment the shadow could extend exactly into the corner, in which case the worst case would be it would create a point. The algorithm would create a point on the horizontal side and the vertical side, but they'd be on top of each other, and so I guess that could cause a problem. Yeah. Okay, so I guess we could just have 4 different values here for the corners. Or maybe it'd be better to have like a horizontal side and a vertical side. Oh, this is getting more complicated, isn't it? We could just go on without worrying about it for now, but then we'd have to come back and modify the algorithm. And I think it is going to cause us some issues. Okay, well let's yeah, I'll come back and think about corners. This code is not going to worry about it. I don't even remember what I was doing. Oh yeah, we wanted to figure out if a point was on the side, and then because I was going to make basically point, make point. So we'd get this from a segment, and then we would see if this position is on any of the bounds. Okay, so let's do it this way. Okay, since we're gonna have probably a separate horizontal side and vertical side, I'll just use an integer because being negative or positive makes a lot of sense. So this will complicate things again, because now I'll need to check both the horizontal and the vertical side, but I think it's gonna be needed. So that we'll be ready to update the algorithm for corners when the time comes. So anyway, we have this make point. So how it'll work basically is if the point, so I'll make it so that if it's greater than or equal yeah, I'll set it to 1 basically if it's greater than or equal to the bounds radius. Okay, so I think that would be the best way. So H, if position X is greater than or equal to bounds radius X, then H equals 1. Position X less than or equal to negative, bounds radius X, negative 1. Okay, and this should be initialized to 0 for default. Oop. Just made a silly mistake there. I'm sure that would have kept me busy for quite a while trying to figure that bug out. Come on. And then we just return new point, position H, V. Okay, so now we can also, maybe we don't even need to tell if it's in bounds, and we'll basically just treat a point on the edge as being out of bounds in terms of the algorithm. I don't think that won't actually cause any issues as far as I can tell. That'll make things a little easier, I think. So point. Okay, so we'll just go like this. Point A equals make point segment A. Oops. Okay, don't need that. Okay, so now we can just check if point, come on, A dot horizontal side is 0 and point A vertical side equals 0 and point B, okay, maybe we will need is in bounds boolean actually, because we're gonna have to test this a few times. So let's go back just a bit. Alright, come on. A in bounds equals, we can have a helper function in here. And this will just be the horizontal side. It's not going to help me there. 0 and vertical side equals 0. Equals point B. Okay, so now I can get rid of this. Okay, now we can just return true. Okay, so now B is out of bounds, so we need to call this find collision with bounds. Well, at this point, since A is always in bounds, then we know it has to collide at some point, so we don't even need to worry about the boolean. So find collision with bounds. Do we need to take a point variable here or just the position? Probably just the position, I think. Well, it will be hard to update it if we need later. So we call segment A, or wait, let's just do it this way. Point A dot position. Then the direction is, forget, did I do the tangent? I think I did A to B, right? Yeah. Which is, well, we actually want to find from B to A, so this is negative. Well, it doesn't make much difference now that I think about it. But this way, okay, well, I'm thinking too far ahead. I know other ways we could probably optimize this by, since we already know what point or what sides point B is on, then we could maybe we'd already know which side it's going to collide with the bounds, but I just want to have one find collision with bounds function that's general purpose, and then if we need to, we can optimize it to separate it into these two different types of line queries, I guess. Okay, so yeah, point A and then towards B, and then the out will just be point B. I'll just overwrite the old one, and then we'll return true. And then if B inbounds, then we'll find point B dot position and negative segment tangent out point A, and then now neither is in bounds, so neither in bounds, see if segment line intersects bounds. So this is definitely the most complicated. So I guess we can see if going from point A to point B has an intersect, and that would give us a new better point A, and then we basically go the other way to find point B. So if find collision with bounds, point A dot position, tangent out point A. So again, if this finds a collision, then we know that the line does collide with the bounds, so we can go point B dot position. Or I guess we could just go from A again, which A has now been updated to the point it collided with the bounds. But now we'd save it into point B and return true, because since we collided with this point, we know it has to collide with one other point at least, well, unless it's on the corner. I'm not sure what would happen then. Okay, well, we'll worry about that later. Okay, so let me write if point A is now a corner. Yeah, because if A is in a corner, then technically it only collides at one spot. So I guess we just set point B to be point A, and then we'd return true. But yeah, I won't worry about that right now, because it's going to be a lot of busy work. But then if the segment doesn't collide at any point, then we'd actually return false. That's actually the only time we return false. Okay. So we actually don't need these vectors, we want the points, so let's actually do this a little simpler. I'll subtract the offsets here. Although light offset. Okay, so point A, B, and then F is segment and bounds, segment, offset, out, A, oops, not how to spell that. Then we move on. Okay, so another way that we can change this that we might not need to create the segment is, of course, it won't let me load it right now, but I guess let's just pretend this little sprite is a light. So if the light is here, then actually there'll be two segments, well, three. Well, there's 4 segments in total, but we're just going to care about the top and bottom segments here. So the top segment will create a shadow that would go out like this, and then the bottom segment would create one that's totally inside the top shadow. And right now, oops, sorry, my voice filter volume is a little high. Let me turn it down just a bit so it won't clip anymore. Sorry about that. And so the way that the game takes care of this right now is just kind of automatically as a result of the way that Unity handles meshes. Basically every time you have a triangle, which is the building block of meshes, so here, here to here, let's just take that for example, we had to be careful to wind the vertices, that is, list them in the mesh data counterclockwise. So we did segment B, A, and then the collision over here. And then down here, the counterclockwise would be, well, the way the game works is we wound them clockwise here, and that tells Unity that it doesn't actually have to render them because it's facing the other way. It's because it would go B, A, and then A collision, since that's the way that we create the segments. So we can actually go ahead and check that now, I think. Or actually no, we won't know if it's counterclockwise or not until we find one collision point, because of course obviously we need 3 to form a triangle. Yeah, so yeah, do that later. So what we have to do, find shadow collision for point A, and then find, or yeah, then here we'll check if triangle is counter clockwise. If not, skip this segment. And then we'll need to find shadow collision for point B. Okay, and then that's all we do now, but there's more we have to do, because if, for example, it's hard to explain without showing, but I think that's as far as we'll go now, but we'll need to again check to see if we need to add more triangles. Let's get this working first, I guess. Okay, so we won't do this anymore. Back to this code. Probably I'm just going to comment it out because it's all going to be changed. Okay, so yeah, we'll do this first. Find a collision point for A, which is pretty simple. I guess we should implement this function too. But let's, I want to do the outside code first. So now we know that the collision will always be in bounds because we've already checked to see if for some reason it won't be, so we don't have to worry about that anymore at least. So we have a position, and then a direction is just, again, because the point is in the, the light is at 0, 0, the position away from 0, 0 is also the direction. So it's really easy. And then I guess we'll need another point here. Hit A. Oops. Out. Okay, so now how would we find out if this is clockwise or counterclockwise? I guess let's just not right now. We can test that later. So yeah, we'll end up pretty much just recreating this code. I'll write a to-do, I guess. To-do check if triangle is clockwise. And I'll know to skip that. So now we just find the shadow collision point for B. And now I'll just use this code basically. Oops, I didn't press the wrong button. Okay, so we already found the collision points, so is that right? I think I got it backwards. Yeah, so this should actually be hit B dot position, hit A dot position. So yeah, this actually, we need to find this backwards because we have to find the point B first to see if it's clockwise or counterclockwise, so I'm glad I caught that. Now the triangles will still be fine. Okay, so now all we need to do is adapt this code for a general purpose, which is pretty easy. Okay, so yeah, now we can't assume that the point okay, so I guess we can just use direction actually. Yeah, because unfortunately we can't, what I was going to say is we can't assume that the point, like the line always goes through the origin, which is what this code assumed, but we can just use this direction. It doesn't have to be a unit vector, so it'll be fine. Now we actually only need one point anyway to find the y-intercept, so that works. Okay, so again, this of course was assuming that the point and direction were the same, but we can just use the direction here, it's no big deal. Okay, so point, oh no, we can just hit point. Oh, I can't do that because hit point is read-only, so. Yeah, so hit, this would be new point. And of course we're going to need to check if it's on the corner or not. Maybe I can just do something like this. Let's call this make point. So yeah, it's not the most efficient because we're going to be doing some unnecessary comparisons here, but it will always detect corner points. We could use the same code, I think. All this is still fine because it just uses a slope and the y-intercept. Okay, so here we had to check if the hit point, yeah, if the y was outside of bounds, and that means it didn't actually hit the horizontal side. Yes. So we do, I guess we could just say hit point dot vertical side. Yeah, if it does not equal 0, because that means it wasn't in bounds. Okay, so just a little editing here. Okay, yeah, I guess we still will need the boolean. So we shouldn't always return true here. We'd want to return, yeah, if the, I guess we'd return hit point as in bounds. Well, no. How would we do this? I guess now we have to check to see if, oh, it could be a corner. Yeah, see, we can't check if is in bounds because this is in bounds actually assumes that being directly on the bounds is out of bounds. Which was useful for this code, but is not as useful here. Okay. So this would always return false because the hit point is obviously on one of the bounding lines. Oh, I'm out of time, but I don't want to leave it here. So what would be the best? I guess the easiest way that I can think of now is we'd say, yeah, if either point is in bounds, but again, if it's a corner point, that's going to cause us trouble. And unfortunately, we do need to worry about the corner points, I think. Even though it's unlikely to happen, we don't want the game to explode if it does. Okay, but let's say to do handle corners. So yeah, for now I'll just won't handle corners because I can't think of an easy way to do that right now. So we have to check if the horizontal side or the vertical side is 0, which means that one of the points is not touching or outside the bounds. I mean, obviously, if they're both not 0, then the easiest way would just be to check if they are one of the corner points, but that's kind of a pain. But yeah, we can handle it. Okay, so let's see. I have a feeling it's not going to work, but just to end the stream, let's check it out. Okay, let's turn off all the lights except for the red so we can see, and nothing's happening, so that's not a good sign. Oh, well, you know what? The reason is because the manager doesn't call to create the shadows. Yeah, find segments. We should clear this at the beginning. I need to make sure to... I might clear it down here. No, I don't. Okay, so that's good. Do I ever clear them, actually? Yeah, it doesn't look like it, so I don't know. Oh, hi Kong Dong. Out of 100%, how far do you think I'm into finishing? Well, this is just a project to help me learn this code. So I'm not planning to make a complete game out of it. But really all I have to do is finish up this shadow drawing and then render one big mesh. So I would say I'm probably about, I don't know, 75% done. Because I already know how to do all that, I just got to get the algorithm working. Which unfortunately is not working yet. Oh yeah, I've heard of Wargroove. I actually am looking forward to that. It reminds me a lot of Advance Wars, which is I'm a big fan of. I think they even said that that was their inspiration. Okay, so unfortunately find segments did not do the trick, so we'll need to come back and figure out what's going on. Alright, well, that's funny. It says 6 batches. That confuses me because that makes me think that it's not even rendering anything. So I don't know why anything I've done would cause this render not to cause a draw batch, unless maybe there's no meshes being created. Maybe it just says every segment is out of bounds. That's kind of annoying. This is gonna really log or slow down the game, but I just want to see if that my hunch is true. Oh, interesting. So that never even runs. What am I doing wrong? Hey Scorpion, that makes next Mario Bros. I think this would lend itself to a 2D platformer. I do have some ideas on how I could use this tech for a game, but I don't know if I'll have time. Okay, so I'm really confused actually because this is segment and bounds is never running unless something's going on here. I did call this, didn't I? Oops. Box colliders is set up. Oh, actually it's getting cleared. I must have cleared the wrong array. Oh yeah. I wanted to clear shadow segments, not box colliders. Oh, cool. Is that somebody modeling a Pokemon style thing? I'll have to look at that. Because I actually really need to brush up on my modeling. Some indexes are referencing out of bound vertices. Okay, so yeah, something is wrong. Actually, it says false, false, false. Does it? Okay, so that, sometimes it is in bounds. So at least my algorithm is sort of working, but yeah, something. Oh, I didn't. Accidentally deleted hit B dot position. I just want to see if we can actually see something. It's still not working. Maybe I started it too soon because I don't know what some of those errors mean. Okay. Valid. What in the world is this coming from? Is finite. Oh, okay, so somewhere we're dividing by 0 or something. Okay, well, we'll figure that out. I bet it more has to do with... yeah, something's just not working right. But yeah, I've already run over, so unfortunately I'm gonna have to leave everyone here on a cliffhanger. I do apologize for that. Tomorrow we'll try to fix this up and hopefully move on to actually rendering our big texture of multiple lights, and then we'll be able to move on to the next project. So again, thanks everybody for coming by, watching and chatting. I do appreciate it. I'll be back tomorrow around 8:30 Eastern, and we'll of course come back to this project, try to finish it up. If you missed part of the stream and you want to catch up, I do have a YouTube channel where I upload all my streams. You can check it out at !YouTube by typing that in chat or in my video description. I also have a Discord channel if you want to chat with me and other viewers. It's kind of small right now, so if you are interested, it'd be really cool for anyone to come in. You can get there the same way, !Discord and chat, or my channel description. And of course, just follow me on Twitch is always appreciated. So yeah, that's it. Again, thanks everybody for coming by, and I hope to see you tomorrow. Have a good night. Bye-bye.